Alright, this time on Captain Chaos's laboratory, we're going to be working on the Vampire Castle from Lemax. It just arrived, literally like 30 minutes ago, and it came in mostly one piece, just the sign got broken off in delivery or shipping. So, I'm going to put the sign in the box so I don't lose it. Alright, this is one of the older pieces. It's a 9-volt house, which are more rare. 4.5 is the most common, followed by some of the older 6 volts, and then we had some of these 9 volts. So, in case you haven't seen a 9-volt house, it has the super small barrel hole. See? So, here is the standard 4.5 volt cord, and here is the 9 volt. You can see that it's a lot smaller. So, if you plug in the wrong power supply, you can damage it. So it's plugged in. I'm only going to turn it on for a couple seconds because it's definitely got a problem. But I'm going to bring it up to the camera. That motor is straining. And then the volume works. So that motor sounds horrible. It sounds if you grab a fan, an oscillating fan, you're a kid and you put your finger in the blades and you make the blade stop, the motor starts to hum. That's what this sounds like. That is not good. The reason it's not good is your house, the fan can overload the circuit and blow or trip the breaker. On your Lemax house, it smokes the circuit board. So because there's no fuse, no breaker, no nothing. So we're going to delve into this guy. So it does have the standard removable base. What I'm doing is I'm feeling how big it is. Looking for any weak spots in the foam. I might have to heat her up. Before it gets too hot, let me take off the tight nozzle. I just have it on a low heat setting, at 200 degrees, 212 degrees Fahrenheit, sorry. Boiling temperature. It's the lowest setting it has. Most of these units are in Celsius, like this one, so it's 100 degrees centigrade. You have to do the conversion. And, try my best to salvage the mat. So I'm just going to slowly heat up the mat. If you leave this in one spot too long, the mat starts to burn and melt, so that's why I'm moving it rather rapidly. Just going on the areas that are the resin versus the center that's plastic at the moment. So that's one of the other reasons I was pushing, is to find the outline of the plastic base. Because once I get it free from the resin, the rest of it's easy. Alright, let's see if that's enough. Sometimes heat helps break the glue down, and sometimes it makes the glue more tacky. And it's the trade-off of heat. But the mat is starting to discolor from the heat, where it goes from a gray-black to a black-black where it's burning off the oxidized plastic. So I want to stop for a little bit and see if I can just work out the glue that's warmed up with a flat spudger. Going to an old school spudger because this is thicker and this is thin and flexible to try and get inside, and kind of use it as a dull knife, and it follows the contour. An X-Acto knife might work too, but you got to be careful that you don't cut yourself, or if you don't care about the base, cut the base. But you also got to be careful of stuff like that. That's a wire for the light that's in here. And this piece is from 2007, since it's stamped into the base. I'm going to try an X-Acto or razor knife here. See if I can get a little better cut. Because I'm also, on this part, I'm stuck in the hot glue. Almost off. This has 3 removable plastic sections, which I'll show you all in just a moment. Right now I'm just dealing with the hot glue, which is stuck to the mat, which makes it just a little bit more difficult. Mat's off. The majority of it, there's a couple itty bitty pieces that tore because they're stuck in the hot glue. Like that piece. I'll set it over here. And this piece. So there's the base. You have a plastic section here, a plastic section here, and the main body here. Looking at it, I'm going to say that we're going to start with the main body if we can, which is the black piece. This glue is partially separated. 1, the heat I applied, and 2, it's discolored, which usually means it'll start to pop. So before I apply more heat, I'm just going to see if I can get the black plastic to separate just with a little tension, and looks good. Right. The hot glue can peel right off. I think I said this was a resin house. It's actually, this part's porcelain or ceramic. Alright, glue's broke free, but there's something catching it. I'm trying to see inside. Ooh, it doesn't smell good, so whatever's binding is getting hot. That's why I didn't want to run it for very long, because there's no fail-safe. Okay, that's popped out. see the speaker. I see the main gearbox. I can see the business end of the motor. You can see the doors have separated from the house. There is definitely something holding it in place. I can't see what it is, so I'm going to pop off these other two plastic pieces to see if I can get more light inside. I'm going to carefully start with this guy so I can get this wire. So we have a circuit board. I was not expecting that, truthfully. Try this guy. And another circuit board. I figured these panels just came off to access the lights, but I was wrong. So, unglued the wires that were stuck to the back porcelain, and she still doesn't want to come out, so there's something hanging up somewhere. There's another motor on the top, so there's two motors in this at the moment. The one on the top is a synchronous motor. And I think that's what it's getting caught on, because that shaft that goes up to this is still attached to the motor. I'm wondering if that's what I'm stuck on. Zip tie in here. So the zip tie is not catching. That's what's catching. Glue. All right. So that was my problem. There was some more glue hidden up high. Far out as she's going to come because of the incoming power wire. So can I unplug that? There we go. Now it's out. So we have 12 volt synchronous motor right here. Being a 9 volt house, it'll still run it, it just runs slower. That's probably the whole reason why they used it. And we have a 300 CA motor down here. We have all the wires that are zip tied right here. Got a voltage regulator here. That's why it's got this big heat sink. I'm gonna separate more of the glue. Get more slack in these wires. Get this out of here. So this is your main circuit board right here on the left, looking at the bottom. And it then sends power to the motor, plural, motors, the speaker, then it shares power over here. This is your distribution board. The power comes in, goes to this board first, gets filtered and regulated, and then goes back here. But this is the main board that has your blob chip and controls most everything. So this one also has a relay. I wonder what the relay is for, but we got to find out what stinks. Something burnt or is burning. You can't smell it, of course, on the camera, but electrical has a very distinctive odor. Whew. So, as much of this stuff that unplugs, the important thing doesn't unplug, which is the motors. I was hoping I could unplug the motors. Motors are soldered to the board. So, yeah, I'm going to have to cut this zip tie. So the synchronous motor is soldered to the board, this guy. The drive motor for Dracula here is connected in this bundle right here. So I'm going to unplug the drive motor and I'm going to plug it back in. This also disconnects the speaker, the micro switches. No, just the micro switches. I'm sorry, the speaker is right here. All these wires are the same color, so it's hard to see when you're that close to them with your face. Alright, this is now turning. It's probably got a shorted main motor, and that shorted main motor is what's smoking because it's not killing power to the whole unit. Probably because this is a direct drive motor and it's counteracting it. So I'm going to let it run for a second. I want to feel this motor and see if it gets warm. A motor will get warm where the windings are, which on synchronous motors is around the outer casing, the outside edge. Also, this motor is loose, and it might be loose so when it goes in the hole it self-centers. So I'll probably leave it loose and not torque it so it self-centers in the hole. Because I can see it's kind of been off a hair based on the grinding edge. It's all cut up from the ceramic house. They only have one side loose, so they're probably using that as a lining tool. It's not a bad idea. That's nice and hot. Thing about voltage regulators, they get smoking hot. Right now that is only bearable for a few seconds. Yeah. I'm going to say it's probably about 150, 160 degrees. They'll reach boiling water temperatures. It's insane. That's why they use this big heat sink to dissipate the heat, because they do get extremely warm. The capacitor looks good. It's not bulged, leaking. That one looks good. It's not bulged and leaking. The diodes and resistors don't have any burns or discoloration. This board, it looks good too. Everything's not discolored. don't see anything that's smoked. I'm not getting that aroma of burning electricity or burning electronics, so I'm going to lean heavily towards the drive motor shorted out. The synchronous motor's working beautifully. It's maybe a hair warmer than this room. This room's about 80. This motor's maybe 85. It's just a hair warmer than the room. So, and 80's warm, trust me. I don't film with the fans on to circulate the air because the camera picks it up. My editor hates it. It has to clean up the audio. But yeah, this laboratory gets warm even with all the LED lighting in here. But it is what it is. This may be just as simple as a bad drive motor. So we got to disassemble it. We have 3 layers, 1, 2, and 3, or if you go backwards, 3, 2, and 1. And the drive motor, of course, is on the bottom, so we definitely have to remove the bottom. We may not have to remove the sandwich, which has the micro switches or stop switches or travel switches. Everybody calls it something different. And we also don't risk losing all the gears. Because it appears that all the screws are accessible without taking apart the stack. It's the outer 4. And then the motor screws are pointing down, so we can take the motor screws out. Might actually have to take it apart. It's a hair out of straight. Maybe. Yeah, I got it. No, I don't. Come on. Part of it's this foam mat. Let's put it on something solid. Oh, much better. Alright, that's 2. And 3. There's the glued in base. And there's the 2 screws that hold the motor. And of course there's your pulley with your belt. We're going to pop the belt off. Might have to replace it. It's vulcanized. It doesn't have a lot of stretch. And now we're going to remove the motor screws. Again, I tell this every time I do this, do your best not to lose these little screws. They're really hard to replace. I have been told that Amazon sells packets of hobby motor screws, but I have not personally searched to verify. So, mainly because every time I throw away something that uses a hobby motor, I keep the screws. Just because I know I drop stuff. I'm sure you've seen me do it many a times. So I'm using the spudger with a 45 degree and a notch to get the pulley to pop off. And let's see if we can get this motor out, or do we have to disassemble the next layer? We are going to have to disassemble the next layer. But we might only have to take out 2 of the screws. so we can just tip it just enough to get the shaft out. All the screws that hold these layers together are the same, so if you decide to take the whole thing apart to replace a gear or re-lubricate it, what have you, don't worry about messing up the screws. The entire stack cluster is the same set of screws. There we go. So I've cut one wire, so the motor is now out of the circuit. What I want to do now is plug this back in and make sure that the unit still does what it's supposed to, just to make sure it's not one of these switches. So this is spinning. Nothing smells bad. And if you notice, the reason I'm cutting these back, a little tip for y'all, is so you know which wire goes where. So this wire is the black, and this wire is the red. So when you resolder them on, or twist them on if you don't have a soldering iron, you can put the color on the right wire so it's not spinning in the wrong direction. So now what I'm going to do is I am going to test this motor on my power supply. I know this motor runs at around 3 volts. You're generally a 3 to 6 volt hobby motor. So I'm going to set my meter for 3 volts, and I'm going to see if it spins or if it shorts out my meter. It's spinning, but it doesn't sound good. I'm wondering if maybe we have a bound up set of gears that's causing the motor to overheat. Let's take a look. No, gears are moving freely. Doors slide on their tracks. Gonna reintroduce this to the circuit and try it without any load and see if it causes a problem. Because nothing was working before and it smelled horrible. So there's definitely a problem. Once I took this out, this motor started spinning. Usually that's indicative of a shorted motor. But the power supply I plugged it into is saying the motor is not shorted. It is spinning. It doesn't sound good at first, but it started to sound better after a couple of seconds. Might just end up replacing the motor anyway. Alright, juice. Motor spun for a couple of seconds. And put the motor back in and put it under a load. Also, that way the micro switches do their thing, because with the motor out, it only is going to spin because it's not going to spin back because the micro switches haven't shifted. So But yeah. So I'm going to go ahead and put this back together real fast. I'm going to double check the gears. The gears look good, but I'm going to double check them, make sure nothing is bound. Unless the belt's slipping. But the belt burning smell is different than the electrical smell. So that's what's confusing me. So. It's always interesting when you take it apart and then it starts working all of a sudden. You don't know why or what caused it to fail in the first place. Then you have to sit there and go through everything. And sometimes you have to speculate. I was leaning towards a defective motor because as soon as I unplugged the most common cause, everything started functioning. So, defective motor, voila. But it seems to be okay. So here's our gear cluster. We have the standard 10 tooth right there. We have some transfer gears. These two special gears that are two sets of gears that are pinned together with a little spring. This is what opens and closes the doors. So you want to make sure that the doors are timed, meaning that make sure when you put it back in, the doors are equally spaced apart or completely closed, because you don't want one door to open farther than the other, because two things, it can bind or it can throw out the micro switch that tells it to stop. The 10 tooth gear is broke, so that might be the problem. It's wedged. It may have just been wedged and causing this motor to overheat. So I'm going to do my best to show you. First, let me find a pointy tool. That'll work. So here's the gear cluster. Here's the gears. And the gear is split right there. I don't know if you can see that right there. So what happens is, when it's under a load, it's turning. So it's being forced by the motor. It's right off the pulley. When that tooth that's on the opposite side of the separation of the rotation hits the this gear, which then in turn turns off your other gear, and the gear that goes here is pressed onto the bottom right yar, it opens, and then it causes it to be out of alignment, and it causes the tooth to smack the tooth and not the tooth to go between the two teeth where it's like a cog. So I'm going to have to get a gear. We're going to have to replace that gear, put the motor back in, and run another test, and then see if it gets hot. And then if it works, I'm going to let this house run for a while, and we're going to stress test it. Basically, I'm going to let it run for half an hour, an hour. Probably let it run like this, where it's not in the house, because all the moving parts are right here. So we have the door, the guy that comes out, and the spinning shaft. Nothing else in this house moves. So this is the only part, this center section, that is of motion. And we'll let it run, and we'll see if the house fails, if the motor overheats, if this motor overheats when it's under full load from its own power source. Also, while it's out, I'll double check how hot this guy is getting compared to what it's supposed to get. I won't be able to read the chip number due to the capacitor soldered right against the face, but I'll look up some basic power regulators. I have some lying around. I can just look up some part numbers and get a range of temperature. And then you can use one of those thermal guns that shines through the laser beams. If you have a candy thermometer, you can rest it up against the side, because those are way accurate. I don't know if a forehead or ear monitor would work, an ear temperature gauge for you know, if you have a fever. Plus, I don't know if it goes that high, because I know a fever is 108, but this thing might hit 250 degrees. So, yeah. But trying to give you some options if you're trying to do this at home and see if you maybe have a bad regulator. The regulator is probably in here to regulate the power to the components on the board, since this is a 9-volt house with a 3-volt motor, a 12-volt motor, and a chip that runs on a volt, the blob chip as an example. And the speaker chip runs on 3 to 9. So this might be regulating power to everything because it has multi-powered components, and this is probably going to be regulating this board because this board will run at a different voltage. This, I believe, is just hot wired in where it's soldered on the bottom. I believe it's coming right off of the incoming power terminals from the switch. So when these wires transfer the power to this board, where the runs are, that goes to the components, the speaker chip, the speaker, this motor, I believe these two red wires right here are soldered to those two incoming tracks, which is the hot and the negative for direct drive. Because this is a 12 volt running it at 9 volts. You can't run it much lower because most 12 volt motors will not run below like 8 volts as an example. So yeah, so I am going to find a gear and replace it, put the motor back in, reassemble it, and we're going to test it. So bear with me. Be back to this in just a couple of minutes to save on time. You've seen me replace gears before. You saw how to take it apart, reverse to put it back together. Alright, I am back. I got it all back together, and I did test it before I changed the gear, and it did stop. So, because the crack is so small, there's the gear on the spudger where the crack is. So, and I haven't done a stress test, but it does do its thing. The door is open, Vampire comes out, does his little speech, goes back in, door's closed. So, the motor, I am going to change the belt. This is still the original belt. That's why there's only 2 screws holding it into the base and not all 4 at the moment. Turn the volume down. When it got caught on this, the cracked tooth, or the crack in the gear, the motor is still turning, and it was smoking the belt. So the motor would turn for its time to move him in and out, and in that time it was spinning. The burning smell was actually the belt. So I'm going to resolder the motor back on here. That's why I didn't cut it short. And I'm going to let this run just like this for like a half hour or so. But I want to change the belt. I am going to put a new belt on it. Right now it's got the old belt just for testing. But the old belt does slip intermittently. So, but because this uses micro switches, the motor will not stop turning until those micro switches are engaged. So part of the reason it smelled so horrible is that motor is spinning and the micro switch isn't engaging, so the motor doesn't know to stop. Uh-oh, that's not good. Just the door got stuck. This is why I wanted to do a stress test for something like this. So it might also be the fact that it's not inside the house. These little tabs help line it up in the porcelain, keeps the doors from shifting. There we go. So, but this is the whole point of the stress test, is to see if something fails, just like it kind of did. So, kind of, it was obvious it did. So, this is why usually when I fix a house, I let it run off camera, unless you want to sit here and watch it for a half an hour, make these videos ungodly long, in case something like this happens. So, I'm gonna put it level, see if that helps, and we're gonna let it run for a while, and if nothing else goes wrong, then I'll just change the belt and put it back together. So, all the lights are working. I'm not getting any deviation in power. Remember I was saying a little bit ago about the doors have to be placed right or else they won't work right. That's what happened here. Just make sure the gear is still touching. There we go. Looks like I'm going to have to do adjustment on the timing. Oh, maybe it's working now. The doors have a gear. That's that spring and that stack gear. So when the gear stops turning, because the doors are shut, the rest of it can still work, and the springs act as a clutch. So I might be a little bit out on the teeth. See if I can. Let me try and zoom in so you can maybe see this. So, and it could be lubrication because yeah, they're sticking. But so here's the gears. You see how they're rotating but the doors aren't moving because they're trying to open? That's what this spring in here is for. That's acting as a clutch. So it disengages the top part of the gear. I just smacked it. There we go. But what's happening is you can see the doors aren't closing now. It's also because this guy's not going all the way back. So I'm going to have to reset the timing on the gears. I probably screwed up the timing a little bit when I replaced that 10 tooth. Alright, right now the motor is turning, but the belt isn't. It's slipping again. I'm off a screen, sorry. So the motor is turning, but the gears aren't because the belt's slipping. So I am going to change the belt. I just put tension on the belt and the door's closed. So this looks like it has a combination of issues. Mainly it had a broken gear. And then the second issue being the belt slipping because it's burnt. So I'm going to let it close again. And then I'm going to turn it off and change the belt out. And then I'm going to let it run. And hopefully that'll take care of it. I'm going to double check the timing on the doors. They seem to be working okay again. But I'm going to double check the timing on those teeth and make sure that they're both set with the clutch, the spring clutch they use. Usually they're self-setting, but we'll double check. Resolder this and put heat shrink back on it. I'm going to throw away this broken gear so I don't accidentally use it on something. And we should be good. So I'll be back in a little bit. I'm going to fix the belt and then we're going to let it run. And I'll let you know how it did, and it's probably half-hour stress test. Okay, I've had this thing running for about a half an hour, and I put a new belt on it. It's working a lot better. The doors got caught once, so I put some lubrication on the track because it's plastic on plastic, and the doors are working a lot better. They're opening all the way. The guy comes out all the way now. The lubrication I use for the gears is a white lithium grease or a silicone grease. But the plastic on plastic, since there's no gears, it's just a plastic track. I've showed it before, but I use the non-stick dry film lubricant because it doesn't stay fully wet, so it doesn't attract dirt and dust. I put that in there so you can see that it's still rotating. That's the only reason the wire's in there, is to show you that that motor is actually turning. So it doesn't like to be turned sideways when you're working on it. I'm not sure why it does what it does when I adjust its height. So if I leave it flat, the door is open and the guy comes out, but as soon as I tilt it, it only goes halfway, and it might be that one of the micro switches is not fully disengaging when it's tipped at an angle. But most people's houses aren't sitting at an angle because they might tip over. So, but the volume works. Just have it turned down. I am going to re-glue the speaker in because the speaker is, it flops. It actually, when I tipped it, it's only attached on the top. So I am going to glue that in before I put this thing back together. As you can see, it just fell out from me touching it. It's just this glue is so dry, it no longer has any adhesive properties. So, so at the moment, you notice this isn't spinning. I think you might have two problems with this piece. There we go. This is a CCW motor, and if you watched any of the other videos regarding synchronous motors, it's counterclockwise rotation, and there's a paw on the inside that stops the motor from spinning backwards. I think the paw is getting stuck. And what's happening is when it gets stuck, it can't turn. And then when you reset the power and it tries to change directions, it releases the paw. That's why I quit turning, because it did it once to me, and when I looked at the motor, I thought maybe it wasn't spinning, and when I put the wire in, it started spinning. So I'm thinking the paw on the inside that stops this from changing polarity or going backwards is getting stuck, since it just did it twice right now, and it's only done it one other time in the last 30 some odd minutes. So yep. So it's going counterclockwise. Now with the paw, if it worked right, it would stop it from turning, but so it works intermittently. See how it was stuck and then it just jerked and moved? Because the paw engaged. That's the paw, that clicking sound is the paw skipping on the gear. And now it works, because how these motors work is when you turn them off and on, when you turn it on, it goes one way. When you turn it off and on, it goes the other way, and they go back and forth. How they make it only go in one direction is they put a plastic paw that as it rotates, it just allows it to slip, but if it tries to go backwards, it engages a tooth or a notch in the base of the motor. I showed it in the Synchronous motor video and the last Lemax carousel. I forgot what they called it, but it would reverse polarity, or excuse me, the city sidewalks. It would reverse polarity because that paw, the end of it broke, so it couldn't catch the cam or the ratchet that stops it from reversing polarity. This one's getting caught too, which is why it's doing that. What you hear is the motor turning, or attempting to turn, and the paw is stuck, so it's either skipping or vibrating. You'd have to open it up to see. So it's probably going to need a new synchronous motor. Yeah, the paw was vibrating and then it engaged and told it to change polarities. And I apologize if you build synchronous motors, if it's not really called a paw. It might be called something else, but it's just a flat piece of plastic with a hook on the end that grabs a notch in the casing. So looks like there's three issues: cracked gear, which I threw away so I don't accidentally use it, a slipping belt, which I've replaced, and a synchronous motor that's starting to fail. You can include the lubrication, but lubrication is lubrication. I mean, sometimes it causes issues, sometimes it doesn't. So I will go ahead and get a 12-volt synchronous motor on order, and it'll probably take a week or so to get here. Synchronous motors are always slow. Actually, real fast, how is this shaft? Synchronous motors come with different shafts. So this has a cammed shaft where one side's flat, so it's like a D shaft. So this is what I'm referring to. You can see it's got a flat side. So when you order synchronous motors, if you can't match up the part number, which this one does not have one, it is a synchronous motor. It is AC 12 volt, 50-60 hertz, 1.2 to 2 watt, 5 revolutions per minute, counterclockwise rotation. That might be another reason. I don't know if you caught the part that it's AC 12 volts. Never mind, this is an AC, so that's fine. Sorry. AC motors do not like to work on DC. And I thought this was the 9 volt DC adapter. I was wrong. This is a 9 volt AC adapter. So, disregard my last statement. So, I will find a motor that'll fit in here. This one is a CCW, which means it automatically reverses polarity and you can't stop it from doing that. It is also a cut shaft. You can see it's cut on both sides, but I don't know if you can tell, it's a much larger shaft. It's a much larger motor. That's what I said about synchronous motors, is when you check them, you need to get all the information you can, because they come in different diameters, different thicknesses, like this motor is much thicker, and they come with different diameter shafts and different style shafts. So the best thing to do is to have a micrometer or a good ruler next to you when you're looking them up, and then try and get all the measurements, because most places like Amazon and eBay, when they put synchronous motors on the screen, they will show sections of the motor with the arrows that tell you it's 27 millimeters by 10 millimeters, and the shaft is 4 millimeters with a D or a X cut or a screw hole. Oh, there's so many variations. Synchronous motors can be a pain sometimes. But I'm going to see what I can find so we can stop this from happening. I've never successfully been able to get the paw to repair when you pop these open. If you haven't seen the previous videos, here is the synchronous motor from the Funhouse from Department 56. So you've got your gear clusters inside. This one is 120 volt CCW AC, because the Department 56 had some 120 volt houses. This one is a double knot shaft with a screw in the middle, which is very important for Department 56, because they actually screw their moving parts to the end of the shaft. Also, it's keyed so it matches. But this one does not have a paw, because this one cannot reverse polarity the way it was built. Same thing. It's too big, it's not as thick, which the thickness doesn't always matter, but it's also 120 volts, not 9. So the reason I have this sitting here is because, believe it or not, you can rebuild motors. The motor itself is going out the windings, but these gears can be used on other synchronous motors that use the same gear pattern. That's the paw. This one does have the paw. I don't know if you can see it right there. That piece of plastic that comes up. So when the motor tries to spin the wrong way, this paw grabs. So since this actually has it, I can show you. This is sitting on one of these posts, like so. Actually, it sits on that one. So what this paw does is when it spins in one direction, the paw is over on the side. When it tries to spin the other way, it gets caught into this notch, which stops the gear. Also, it catches right here on this bow tie, and it stops the motor, and then reverses. Because when these motors get stopped, they reverse polarity. So what they do is they start spinning in the other direction. So this one has a bad paw. This one has a bad set of windings. So the center section is fine. The coil pack inside is bad. So but that is how these things work. That is why they're so expensive. And expensive is relative. But to give you an example, this motor right here cost $9 to replace for the Funhouse from Department 56. And then the motor down here, the 300CA motor, which is this little guy right here, a 6-pack of these are like 12 bucks. And then you have another Department 56 that uses a special synchronous motor. The cheapest you can get that motor is $48. So synchronous motors can be a pain. and I'm going to go research and see about getting that one replaced. I'm going to get this glued back in so it stays. I think the door issue has been resolved. It said I had it running for more than 30 minutes. Other than the doors getting stuck open or partially open because they wouldn't close. I lubricated the two tracks on both sides here. Doors are working beautifully like they're supposed to. Got a new belt. The belt's actually much thicker than the original belt, so it'll last longer. Won't break down as fast if there's a problem where it gets stuck and the motor's trying to spin. I will put where the belt came from. It's an animatronic repair kit from Skull Crane Electronics. I've used them before. I've recommended them before. I will put the information below. Matter of fact, there is the casing. It comes in a plastic bag. But there's the top of it, because I just opened it yesterday or day before yesterday for another house I had to repair. So I will put their information below. I have bought a lot of parts from Skull Crane. I recommend them. They also mainly do the Gemmy products. Those are the big tall animatronic creatures you see at Halloween, or the Santa Claus and reindeer and stuff at Christmas. And everything's decently priced. So, but anyhow, enough with the blabbering on about different things. It's time to do some research, get a motor. All right, so the next time you see this, in a week or two, from me, instantly for you, hopefully it'll be fully functional with a new motor. I will also ask the person, before I just go out and buy a motor, if they care. Because what happens is you can actually just turn it off and on, so it reverses and it starts spinning the shaft. So, some people don't care about that, other people do, so I'm going to send them an email as well. At the same time, I am going to research this motor, so I am going to unscrew it, get the measurements, diameter, thickness. I don't care about the wings. Most motors, when they come, have multi-holes. Some have 2, some have 3 on each side. You can see that they're not straight across. They're kind of tapered in from each other, and that's so they're diagonal, they're straight. So it would be diagonal. So, and I'll measure the shaft size. Now, I've had this question a lot. I'll go over it real quick before I stop. If you get one that's got a round shaft, you can use a Dremel or a file and grind the shaft flat on one side or both sides if necessary. I've done that a lot because some of the older pieces do not have, they don't make the shaft style anymore. So, if it has a screw in the center, like the one over here, make sure you find one with a screw in the center, because drilling and tapping it is a pain. It's hardened, well, that's hardened metal. This feels like aluminum. This feels really cheesy, and it's got a dent in it. So I'm thinking this is a softer material. So, but anyhow, there's that. Shall return shortly with a hopefully fully assembled, functioning house. And we'll get that sign glued back on too before it goes back. All right, see you in a moment. All right, it's back together. I'll turn the volume down a little so it's not so deafening. So, it doesn't like to be on its back, but the camera is mounted from the ceiling, so that's in there and spinning like it's supposed to. The doors open and close. Now, I did have to recess them back a hair farther than normal because there is a protrusion right here that keeps grabbing this door. It's not a protrusion in the wire or the glue. The inside casting of this porcelain is horrible, and I don't want to grind it. That's why you see the door stick for a second. If I grind it, the vibrations could crack the whole thing, and the point is to make it work. I'd rather have it work like this than be broken and not work at all. So the door is inset just a little bit farther than normal to allow perfect or nearly perfect function. What that means is he will not be directly underneath that light, which is the only downside, but it opens and closes. So I was able, after a long time of searching, to find the motor, but it was the only one. So I do have a brand new 9-volt AC synchronous motor in here, so this will always spin in the right direction. Thank God. So, if you have a bad one, you're going to have a problem. It took me over a month to find this thing. And I search every day or every other day when I'm looking for parts. I try different keywords. It was on eBay. It was just randomly posted up there, and I found it a couple hours after it was posted up there and bought it. So I can't link it to you because they don't make them anymore. So that's going to be the problem. It's going to be one of those that you're going to have to search and search and search, and then maybe you get one. And I hate to say it like that, but unfortunately it's the truth. So it's got a new synchronous motor. The volume works. It's obnoxiously loud. I glued the speaker back in, and I'm going to turn it off now so I don't have to listen to it. The sign will get glued on now that it's back together, and I'm going to spray this and stick it on a new mat and then cut the mat out to fit and then ship it off back to its owner. So, rebuilt the mechanism in here as you saw, and new motor in here for this shaft right here, which spins the flying vampire in a circle. It goes in the right direction every single time. Now the old one, I still have it. I'm not going to throw it away. I'm going to see if I can fix the stuck paw. I don't know if it's going to be possible or not, but it's worth a try, since the 9-volt synchronous motors are virtually impossible to find. You might find a parts house that you can scavenge. They do sell them occasionally. Sometimes you can find them for cheap, sometimes you can't. It depends on how much you're willing to spend to repair what you have. So, but rebuilt mechanism here. Glue the speaker back in. The volume issue's been resolved. It was just a bad component. And the glue this broken sign back on. New synchronous motor. It's all glued back together. Now I just need to spray a mat on and trim it, stick it in this box, and get it back to its owner. Hopefully it doesn't get broken in shipping. One of the things I shipped recently did. Part of it broke, and it's a part that it's a one they don't make anymore, and you can't find them anywhere, so that's what sucks. But they're usually packed really good. I don't foresee a problem. It made it here in one piece. I'm hoping it'll make it back as the same. But if you have any questions, concerns, issues, so on and so forth, leave them in the comments or send a message to us directly via Facebook or Gmail. I usually get back to all messages within 2 days, just because it is the holiday season and I'm working 60 plus hours a week for work, 5 to 6 days a week. So a little slower at responding than the off season. But I'm going to glue this back on with some Gorilla Glue. As you know, that's what I prefer. I like it better. It's got a little bit longer set time, but to me it bonds better. This is Sure Bond, the hot glue that I've talked about before. I will tell you I had to do this twice, because the first time I glued it, some of the glue dripped in this gap right there. Got on the mechanism. Guess what didn't open and close? So I had to take it all back apart, pry the glue out after I heated it up, remove the glue that dripped inside, and then recenter it and put it back in. Now, when I glued it on, I had this thing running. So this was fully on, so I could push it in and center it to stop this door from rubbing on the imperfect casting. Because what would happen is the other door would open and this door wouldn't. Or both would open and this door would never close. And you had to either grab it with your fingers or poke it with a screwdriver to get it to shut. So, because every house will be slightly different, the molds are universal, but as the molds get older, more and more castings, there's more and more tolerance issues. So you might have to put this black plate in at a slight angle, or over farther to one side or farther back. There is a little bit of slack around all 4 sides for adjustment and fitting. So just be aware, each house is going to be slightly different depending on which mold it came from and how old that mold was before they destroyed it, and you might have a tolerance issue. Other than that, it's back together. It works. Volume, door, spinning motor on the top. It's good to go. So, thanks for watching. Till the next repair, have a good one.